Yeah, I already started.
Hello everyone, we're back on the air. We were sick this past week and weather has not been very nice, but my throat still hurts a little bit, but we'll do okay I guess today. There was a question that popped up at the rational scientific method group. Let me put the question up there so that it's not really a question, it's how someone interpreted my extinction theory. And I told the fellows over there that I'd be clarifying a little bit of what this theory says. And this is what this fellow says. He says, Bill's extinction theory explains that growing population depletes resources and shrinking population destabilizes the economy necessary for resource exploitation. And he follows this up with a comment that says, you state that a shrinking population and rising taxes due to technological advancements would collapse the Ponzi schemes of artificial economy and leave everyone without incentive. It's like he took bits and pieces, put them together, and put it in his own words, but he failed to represent me faithfully, if I may say so. So I want to clarify some things today about my theory. Again, I'm not so much interested in persuading, convincing, converting, or recruiting. I just want people to understand the theory, and I have trouble making people understand the theory.
You have low ambitions.
Yeah, I guess so. You know, I'm not here to convince. I'm trying to get people to understand the theory, and it's been so hard. And Monkey Mind suggested, he said, you know, maybe people come in with their own ideas, and they see 2 or 3 words maybe in there, and they say, oh, he's saying the same thing I'm saying. And that's more or less like it works out there. And I do have some of that. You know, I gave an interview about a couple months back now to a fellow about extinction, and I saw all the comments that people made in that video. And again, I would say way over 50% did not understand the theory. They're not following what I'm saying for some reason. I don't know. People have their fixed ideas, what they think the theory says, and they're putting words in my mouth and saying, you know, Bill is saying the same thing as I am. I'm not. And I've got an example here because I've been likened, in that video especially, I've been likened to a guy named Guy McFearson. Guy McFearson goes around talking about the extinction of man. What I seem to like about him lately is that he says that there is no solution, that we will become extinct. In fact, he gives a date, 2026. Okay, so now you know.
That's really close.
Yeah, we're
like
less, 6-7 years away from that. So he's got a date now. Okay, he says it's going to be 2026.
Did you give day and month yet?
Well, let me read what he says. Okay, this is what he says. Guy McFearson, he's got a site called Edge of Extinction, and in an article that he recently published, May 14, 2018, that's last week. He says, prediction versus projection, exemplified. In a previous video, he said, what's the difference between a prediction and a projection? And he says that we have a great problem with language in science, and that I agree with, but he didn't clarify it very much. He did clarify what projection means, and that he says it's a trend. Like, if you have some data here and you have a line that the line of best fit plus, error factor there, a range, well, then you can predict. If everything continues like that, you can predict, or maybe project, really, what he said, what's going to happen, in a couple years, 3 years, based on that information. But he never clarified exactly what prediction is. He says, all he said was, well, we use the word predict to do predictions. And that's it. So he clarified what a projection is, and I have no problem there, but he never said what prediction is. But in the follow-up article, which is the second, the one this piece is taken out of, he says, further clarifications. My prediction of human extinction by 2026, which is based on my interpretation of near-term future temperature rise, talking about temperature rise on the planet, does not project into the future based solely upon prior data. My prediction is based upon the combination of several contributors to temperature rise rather than extrapolation from existing data into the future. Okay? So what does he talk about? He's talking about the environment. He's talking about climate change. He's talking about temperature rise. Okay? None of which I talk about. In fact, specifically, I say quite the contrary. I'm saying that temperature rise, climate change, whatever you want to call it, has nothing to do with extinction, should never be raised in an extinction debate. It has nothing to do with extinction. Never in the history of life on Earth has a species or a group of species become extinct because of climate change. Now, you don't have to believe me. You don't have to take my word for it. I'm just saying that's what I'm saying, okay? So now you have it. If someone says, no, Bill Gates said, climate change, no. I'm saying to you right now, never in the history of life on Earth has a change in climate caused the extinction of a single species, let alone of a group of species. Climate change has nothing to do with extinction. Now, am I saying climate change is not happening? Are the polar caps not melting? Is Greenland ice not melting? Are the glaciers in Antarctica not melting? No, I'm not saying that. In fact, data seems to show to me, for what I've seen out there, that there is climate change. The Earth is warming up, very likely because we're 8 billion people throwing all kinds of junk into the air. That causes a little bit of a greenhouse effect, and I think that's warming the planet, or could at least contribute, if not being the main cause. So there is climate change. I'm saying climate change has nothing to do with extinction. And anyone who uses environmental questions, conservationist, climate change, is my enemy. They're bringing stuff that has nothing to do with extinction. And one of those is Guy McFearson, so I should not be ever compared to him. Okay? But it turns out that, Guy McFearson also says something about the economy, which is what I'm talking about. But he touches it very lightly. It's very hard to find anything where he puts his finger on the economy. And it's like he puts everything in the same boat. He says, oh, we've got, climate change. We have peak oil. We have the economy. It's like he throws everything in there like, I'll hit it with one of them. But everybody knows that one of those, all those people who are into extinction, know that one of those is going to cause our extinction. If you cover all the bases, you're going to say, well, one of those is going to kill us. But what does that mean? You still don't have a mechanism. You cannot still tell me how man is going to become extinct because climate changes or because the economy collapses, whatever that means, or because peak oil, whatever that means, So this is the issue. And this is what Guy McFearson says in regards to the economy. He says, this article is from 2009, says, people often accuse me of inappropriate behavior because I propose bringing down the industrial economy. He's a communist, okay? Interestingly, nobody seems too concerned about the morality of the big banks as they devise ways to profit from economic collapse. And in parentheses, to be fair, some are advising their clients how to profit too from a collapse they foresee within 2 years. Okay, so he has no clue how the economy is going to collapse, but he is trying to propose that the industrial economy will collapse for mysterious reasons that he never explained the mechanism. And he says it's good that it collapses in certain ways because it's evil, it's immoral. And I've got more on that here. He's got this other article, if I can put it up here, is terminating the industrial economy a moral act? Also from around the same time, 2009. And, oh, okay, that's, he says, I guess it's the same one. Okay, sorry. But he's got another one here. Got a couple. He says, am I an optimist? Same thing. And he says, civilization will collapse for any number of reasons. So he doesn't have a clue. He just any number of reasons. Climate change will likely be a primary driver. When, not if, but when industrial civilization reaches its overdue end, we agree there'll be no fuel in filling stations, no food at the grocery stores, and no water coming out of the municipal taps. Unpaid first responders will return home to care for their families. The world's abandoned nuclear facilities will melt down catastrophically. And again, he then rants about the environment. And again, the question here is, he hasn't given us a mechanism. All he says, the economy will collapse, whatever that means to him, whatever that phrase means to him. He wants it to collapse because he says it's evil and immoral. And then he says, when that happens, which is where we agree, again, tidbits we do agree on. He says, when that happens, there will be no gas at the filling stations. We don't care too much about that. At least I don't care about that. And the key one, no food at the grocery stores. Why? Why won't there be any food at the grocery stores? I mean, he just mentions that, but what causes that? And again, I have a mechanism, or I propose a mechanism for that. He doesn't.
He says it like matter of fact.
Yeah, he takes it for granted that the economy will collapse and suddenly there won't be food at the stores. And nobody knows why it collapsed, how it collapsed, why there won't be any food at the stores. There's no mechanism for that. And again, he writes this a long time ago. Now he's a total environmentalist. He believes that by 2026, it's the overheating of not of the economy, but of the planet, the temperature that's going to cause the extinction of man. And here's a final one where it shows that he is a true communist. And I know about communism a little bit. I've been in it all my life, so I can spot a communist when I see one. Agrarian anarchist professor Dr. Guy McFearson speaks to Kim Hill. This was in New Zealand. And this, again, has to do a lot with politics. Remember, it's the New Economics Party in New Zealand that interviewed him. And the person just states what McPherson said. He says, he told us that climate change activists are divided into those who want to save the industrial civilization and those who don't. Seems an awful choice to most of us, but logically he is right. Those who love the planet and want it to survive should hope for economic collapse. Which is opposite of what I'm saying, because I'm saying economic collapse will cause the extinction of man. And here this person is saying, quoting what McPherson said on New Zealand TV, that we want it to collapse, so we want the economy to collapse so that we can all live in the New World Order or whatever that comes after that. So it's opposite of what I'm saying. So again, all I'm trying to say is McPherson says things that have nothing to do with my theory. I should never be compared to him, at least equated to him. Okay, compared maybe, but not equated. I'm not saying the same thing he's saying. Now, McPherson's not the only guy out there blabbing about, the extinction of man. There's several people. I just pulled a couple of the most prominent ones. Let's see if I can get one here. One is this guy. Where is it? His name is Ander Sanberg. Okay, 2008. He says humanity could be extinguished as early as this century by succumbing to natural hazards such as extinction-level asteroid or comet impact, supervolcanic eruption, global methane hydrate release, or nearby supernova or gamma-ray burst. Perhaps the most probable of these hazards, supervolcanism, was discovered only in the last 25 years, suggesting that other natural hazard may remain unrecognized. And then he adds here, he said, the risks from anthropogenic hazards appear at present larger than those from natural ones. Although great progress has been made in reducing the number of nuclear weapons in the world, humanity is still threatened by the possibility of a global thermonuclear war and a resulting nuclear winter. We may face even greater risks from emerging technologies. Advances in synthetic biology might make it possible to engineer pathogens capable of extinction-level pandemics. So what does he propose? He proposes first natural disasters taken out of paleontology, asteroid strike, volcanism, which is proposed for the Permian extinction. And then he says, but those are minor in comparison to the human-made ones, which are the nuclear weapons and all those bugs that the CIA is, making in their labs and will release upon the world, or maybe the bugs escape out of the lab somewhere. So it's all, technology related, okay? And then we have another famous fella here. I think it's, no, here he is. His name is Nick Bostrom. He's been at it for many years. He's also works at the Future of Humanity Institute of whatever. And he says the great bulk, in one of his papers, 2012, he said the great bulk of existential risk in the foreseeable future consists of anthropogenic existential risk. Again, humans, we're going to kill ourselves, okay? And we're going to do it either deliberately through bombs or accidentally through bugs. And that is those arising from human activity. In particular, most of the biggest existential risks seem to be linked to potential future technological breakthroughs that may radically expand our ability to manipulate the external world or our own biology. For example, there appear to be significant existential risks in some of the advanced forms of biotechnology, molecular nanotechnology, and machine intelligence that might be developed in the decades ahead. So all these people, they're thinking about technology. First, they're thinking about catastrophic agents, catastrophes, asteroids, supernovas, volcanism. And then they say, well, we can probably handle those, but what we cannot handle is our own inventions. We cannot handle the nuclear weapons, and we cannot handle the bugs or the robots that, go amok. And that's where we differ, because I'm saying none of that has anything to do with extinction. Never did an asteroid cause the extinction of a species on planet Earth. Doesn't mean you have to believe me. I'm just saying that's what I'm saying, okay? So if anyone says, oh, Bill Gates says asteroid, no, I never said asteroid. I don't say volcanoes. I don't say bugs or robots. Nuclear weapons is a different story, because I think nuclear weapons might participate at the end of the story. Okay, very likely. But what does nuclear weapons mean? It means that for a struggle for resources between competing mafias, the Russian mafia against the American mafia against the Chinese mafia, so they throw maybe the nuclear weapons at the end. It could happen. It might happen. I don't know if it will, I'm not suggesting it will or that it won't. I'm saying there's a possibility of it happening, but whether it does or not, it's got to do with competition for resources. So we're back to, resource. And what's the most important resource in the world? Food. In the end, it all comes down to food, okay? So, I want to clarify some points on that. First of all, I'm not saying that getting back to the original question here, let me put that back up here if I can find it. Here. My theory has nothing to do with shrinking population or rising taxes. Not specifically. All I'm saying is that if population shrinks or doesn't grow, which is really what I'm saying, I'm not saying it's going to shrink. I'm saying that we're growing at a slower rate. That's what I'm saying. We're growing at a slower rate. If everything continues as it is now, we use the word McFearson defined projection. And what does projection mean? It means that by the year 2050, mid-century somewhere, we get to zero population growth. That means one person is born, one person dies. There's no growth on the planet as far as population is concerned. Why is that important? It's important from an economic point of view because ultimately our economy runs on demand. And demand is population, ultimately. You can get better products and you can make them better every time. People say, oh, they're going to buy them. Yeah, but if you don't have people buying them because, we don't make people and the population grows older, et cetera, other problems related with that. If you don't have consumers, then you don't sell more cars, you don't sell more services. And if you don't sell, you shut down your plant, you merge, you drive out competitors, all these things happen. And what does that mean? It means more unemployment. And I think that cycle is inevitable as population nears a zenith,
peak.
No, there's another. It's growing. It's growing. I got the word hypotenuse. That's not the word I want. I want the word. The straight line on a graph, whatever it's called. I can't get the word right now in my head. Anyways, as the curve approaches a flat end, okay, at that point, we're not growing. And if we don't grow, there's no demand. If there's no demand, companies shut down because they can't just produce newer products and get the same profits they had before. We're always looking at having more people next year. Our global economy is an inverted pyramid scheme in which next year you expect more to sell more than this year. That's what a successful economy is like. The only way you're going to get that eventually is with growing population. And until today, population has grown on the planet since days immemorial. Supposedly we were like 200 million at the start of the Christian era, and now we are 8 billion. So it's always grown, and that's been good for the economy. But what happens now when you reach a plateau or you even begin to decline? You have less people more people are dying than are being born. And now you have less demand, and you have less demand, and you have problems. The companies, the suppliers have problems. So that's one issue. The other one is unemployment. More people unemployed are maintained by people who are employed, okay? But even before all this, before we go into all this analysis, which I don't really want to get into today, because I want to get the main points across, and I don't want to be confused with some of these people like McFearson and Bostrom. And what I'm saying is, first, we got to start at the beginning. And the beginning is, does the extinction of man belong in science? Is it a question of science? And or how do we get it into science? I'm saying it is a scientific issue, and it goes like this, more or less, the argument. What is science? According to me, it's rational science is rational explanations. If you want to have rational science, you have to define your terms, and you have to have rational explanations for phenomena. That's my starting point. Explain, you can only explain a consummated event, something that happened in the past. So something happens, now you try to explain it. How did that happen? Well, the extinction of man hasn't happened, at least as far as I know. As of today.
We're still here.
Nobody has told me about it. Nobody's notified me. I have no evidence of it. I have no evidence that humans have become extinct, okay? So then the question is, does speculation about the extinction of man belong in science to begin with? Or is it just, is it astrology, crystal ball? What are we talking about here? And I'm saying the theory, my theory, has to do not with man. Man is the wrong word to put in there. I'm talking about mass extinction. I'm saying that what I'm trying to explain is the mechanism of a mass extinction. So do we have mass extinctions that happened in the past? Yes. Now we have a subject matter that belongs to science. We have to explain all those bones that we see in the layers of rock, all the way from the Cambrian. Well, those animals are not around anymore. When you kind of build them up, you find out that there were animals that are no longer around. And the number kicked around is 99% or thereabouts of animals that ever lived are no longer around. So there's been extinctions in the past. And in some cases, when you look at the layer of rock, you see massive extinction where many species died at the same time. So you have the background extinction, you know, an animal here, another one there that die along the, you know, as time goes through. And then you have mass extinction when many collapse at the same time. And that's what I'm trying to explain, because I'm saying that humans will die in a mass extinction, not in a background extinction, but in a mass extinction. And so what I'm trying to explain is the mechanism of a mass extinction. Then, once I have that mechanism, that cookie cutter that I can use in any age, I'm going to extrapolate that to man. I'm going to say man cannot avoid that same mechanism. And if I can show you that man cannot avoid that same mechanism, then I've got a theory for the extinction of man that hasn't happened yet, but that we're projecting. We're conceptualizing how man can become extinct because he can't do anything about the mechanism that caused the extinction of animals in the past. That's my argument. Again, you don't have to believe it. I'm not here to convince you. I'm saying that's my argument. So get my argument right if you're going to beat me up, but don't misquote me. Okay, so what I'm saying is animals in the past died when their food, when their food sources ran out. In other words, I'm saying that the definition of the word mass extinction has to do with the word food. What collapses in a mass extinction? I'm saying the whole ecological pyramid collapses. In fact, what I'm saying, it overturns. We have the many chasing after the few. You have the many carnivores chasing the fewer herbivores, which are chasing after inexistent food sources, primary sources such as plants. So that's what I'm saying happens. The pyramid overturns. And I'm saying that's what happened in all these extinctions. We don't need volcanoes, we don't need asteroids, we don't need supernovas, we don't need any of that. We don't need nuclear weapons. We can do it alone with food. Food disappears. What disappears is the food under our ground, the vegetables.
What's the step-by-step of how it
Well,
happens?
I don't want to get into that step-by-step. Not today, because again, I'm trying to get the big picture, and I'm having trouble already with the big picture. Okay. People misquote me, and so I don't want to get into the details because 99% of the people who attack me, they want to talk about man, and I don't want to talk about man. I want to talk about extinction. I want to make sure that my theory is about a mass extinction, okay? I want to show how dinosaurs died. I want to show how, synapsids died. That's what I want to talk about. People don't want to talk about that because they don't understand anything about that. They say, oh, no, but I know a lot about economics. And I don't care if you know a lot about economics. I'm going to talk about extinction, not man.
Well, I think the reason people talk about man specifically is because their theories revolve around theories that only affect man. For example, technology. You can't really talk about the extinction of T-Rex, that they came up with artificial intelligence and that took the T-Rexes out.
Well, like I said yesterday, I don't think the T-Rexes invented nuclear weapons. I don't think they nuked each other
to
death.
That's my point. I don't think they can't extrapolate technological apocalypses back to the T-Rexes, so they just satisfy themselves with asteroid or climate change killed the T-Rexes.
And I think that's where we should really begin. Right now, paleontology, these are the official theories of paleontology, are the number one runners, the ones people believe. Dinos died because of an asteroid. Permian synapsids, mammal-like reptiles, they died because a volcano exploded, okay? And if you go to Triassic, you've got other theories, all catastrophic, all having to do with the environment. And that's why we have all these environmentalists like McFearson and so on talking about the environment. They're saying, oh, we have, the world is on fire. We're heating up the planet. The ice caps are melting. And that's going to kill us in 6, 7, 8 years. This is what is out of this world. This is what has no justification. We won't die because climate changes. We're going to die when our food sources disappear, and we have to explain how those food sources disappear. they're going to disappear in the same way they disappeared for the dinos, for the Carboniferous amphibians, and for all these other species that existed before us. And, you know, another thing that should be kept in mind, what people, you know, usually try to debunk my theory, is that they say, well, you know, we're different than the animals. We are humans. We have intelligence. We have technology. We can foresee events, and we can react to them in advance. And I'm saying none of those things. Technology, intelligence, foresee, you know, the ability to foresee events and react. None of those are antidotes to extinction. Now, I'm not saying you have to believe me. You have to accept me. Well, I'm saying that is what I'm saying. So please don't misquote me on that. I'm saying that there is nothing we can do about extinction. And there we agree with McFearson. You know, he says, you know, we can't do anything about extinction. It will happen. And I'm saying it will happen. So don't run for the hills. Don't, you know, just live your life today as best you can until it happens, because, you know, you don't have that much to live, maybe. And again, I think it's going to happen quite fast. And all we need is a global economic collapse. And the last thing I'm going to mention about that is that when I say economic collapse, I don't mean what all these other people say. I mean something totally different, which people have not put their finger on. And I'm the only guy that comes up with that phrase. So keep the phrase in mind. Money disappears. Money will be no more. Money will have no value. That's what economic collapse really means. So when people talk about taxes and population increasing, or that we're going to overflow the planet, you know, they're not quoting me. They're not saying what I'm saying. I'm saying that money will disappear. And a lot of these people will object to what I'm saying. They'll say, no, how can money disappear? They believe in extinction, but they don't believe that money disappears. And they believe in economic collapse, but what they mean by that is not that money disappears or has no value anymore. And that's what I'm saying. And now, again, I'm not saying you should believe me, that you should accept what I'm saying. I'm saying that is what I'm saying. I'm saying money disappears. Money will be no more. There will be no incentives for people to produce or distribute food, and that's why we die, because food sources disappear as a result that we don't produce them. We have no incentive to produce them. That's what I'm saying. Now, whether you accept what I'm saying or not is irrelevant. What I'm saying, please don't misquote me. Otherwise, you're raising straw men. Okay? And now on with other subjects.
No, that you have to show.
Well, I needed to clarify that because
but that goes into what I was going to ask you anyway, which is what common misconceptions people have of some of your theories. What other misconceptions are there, for example, of your extinction theory, besides attributing it to weather?
I think the main issue is that, again, what Monkey Mind said, I think he hit it pretty much on the nose. He said, he says, people come with their own theories. So they say, oh, look, the ice caps are melting. And so they read about, or they hear people like McPherson talk about, you know, the fact that there's global climate change. It's the temperature is rising. It's going to rise supposedly by 2 degrees in the next 10 years or whatever. And that somehow is going to cause, some way, the extinction of man. Okay? And so this is one issue. The issue is that people hear that, and then I say, we're going to become extinct. And people say, oh, see, Bill Gates agrees with me. See, he's saying that, you know, all this environmental catastrophe is going to happen. I'm saying, no, I'm saying something totally different. I'm saying, you know, it's going to be food. And that's where we run into trouble, because people are not paying attention to food. They're thinking about peak oil, which is also part of our economic system. So they say, well, you know, once we run out of oil, we can't run the world, so the world's going to collapse. I'm saying we're never going to get to peak oil. In fact, now they've invented shale oil, and they're doing fine with that. So, you know, maybe we import oil from Mars for all we know. I mean, peak oil is not going to kill us. What's going to kill us is when the money disappears and we have no more incentives to go to work or to sell or to produce things. Then we're going to be in trouble. But how we get there is a long story, and I don't want to deal with that. I'm just saying that is what I'm saying, that that, you shouldn't misquote me. I'm saying that money disappears, and because money disappears, food disappears. And then we starve to death, we kill each other, we have cannibalism, maybe we throw the bombs as a result of that. But it's going to be food, or the step prior to that, the elimination of money, the loss of faith in money, that creates this whole mess. Okay, and that's what I call an economic collapse. That's why I talk about that. But other people mean something different by the term economic collapse. So you have to be careful to say, oh, Bill said the same thing as this other guy. No, check to see what he says and see if anywhere you will find anyone who ever said to this day that money will disappear, that money will be no more, that we lose faith in money. And I don't think you'll find anyone out there who says that. I'm the only guy who says that. And what was the other one? Well, not only, I guess, for extinction, you're saying any theory for that matter.
A lot of theories.
Yeah, in physics, we kind of do an about face here and change the subject. A lot of people misquote my theory. And one of the biggest misquotes that really drives me up the walls, because it means the guy didn't read or didn't understand exactly what he was saying, or didn't read enough. And that's that they confuse the thread with a rope. Rope and thread are two different things.
That's a common one?
It's a very common one. People say, oh, he's the swinging ropes. Ropes don't swing. Ropes are always straight. Okay? Here, where's my rope? Ropes are always straight. They never bend. No bending, okay? Ropes are always straight. We got that? Okay? Now, the thread, here I have a...
I use the same rope.
Well, I guess, yeah, think of this as a thread, okay?
No, I mean, like, this is a thread. One of these.
Well, yeah, but it's tied at the end. I don't want to break it. So, assuming this is just one thread, okay, then yes, this is what the thread does, especially in the case of magnetism. But that thread should not be confused with this rope, the mechanism of light, which is, let me put it here in the center, which is a torsion along the rope. That's different than magnetism, which is a spinning of a thread. So thread and rope, two different things. People constantly confuse them. Make sure you understand what is the thread and what is the rope. Separate them. Don't confuse them.
Isn't it easy to show with that rope? The rope is two threads, basically.
Yeah, and
the
people kind of understand it, but when they're saying, yeah, Bill says about swinging ropes. No, rope is always straight. The swinging thing is the thread, okay? So that's one thing that always people get wrong. Many people get wrong. Another one is that, people don't spend enough time understanding what is an object, what is location, what do we mean by motion. And they say, well, yeah, I understood. And they haven't understood. They haven't understood because when they try to say stuff, they immediately run into trouble because they don't really know what they meant by motion, by location, by object.
What's an example that they get wrong?
Let's see if I can come up with an example. Well, many times they treat concepts as objects because we're so used to doing that. They might say, one word that always gets them is the word angel. And I'm saying, is angel an object or a concept? And they typically say it's a concept or treat it like a concept. And angel's an object. I can draw an angel for you. He's got wings. He's got a little plate on his head, gold plate or a ring. An angel is a human being with wings. That's what an angel is. So an angel is a physical object. Now, you're saying, well, but there are no angels out there. Now you're talking about existence, whether they exist or not. We're not getting to the word exist. And again, people confuse also the word object with the word exist. They immediately say, well, but there's no angel out there, no such and such out there. And they confuse it again. We're not talking about the existence of the object. We're just saying, what is an object? And, a square is an object because it has shape. And you say, but squares don't exist. Of course not, because you're talking about existence. And again, people confuse object with exist. And there's many things like that, little things that show that people have not paid attention to what one is saying or have not read enough or really absorbed, what one is trying to say there.
Well, it's hard to leave your assumptions at the door.
It's a new language. It's a new language because it's a restrictive language. Look at my definitions. They're all 1 millimeter long, you know. Object, that which has shape. You look at some of these definitions out there, like the definition of science, you can pull it up out of Wikipedia or, you know, anywhere on the internet, and they're two meters long. You know, the guy says if, ands, and but, semicolon, comma, you know, they've got all these things and if and whens and buts. No, science, rational explanations, boom, period. We're done. You know, the longer you make your fundamental words, the longer the definitions, the more trouble you're likely to run into. The foundations of physics have to have very short definitions. Then they're solid. But if you put if, ands, and buts in there, you know, then you're going to run into trouble. You're very likely because why did you put those? You had to put those to cover every base. That's the first symptom. And the second one is that the other guy can tear it apart easier because he says, oh, but you said here and this, and here I have an exception. And that's where they also run into trouble. So the shorter you make it, it's the harder to debunk first. And second, it's crisp. It's people understand and say, okay, object is shape, period. We're done. You don't have all these, well, if you can see it, if you bring another object and touch it, you know, if you run an experiment, you know, it's got to be straightforward. And again, you know, location, set of distances, distance, what is distance? Separation between two objects, period. You know, it's got to be very short, very concise, and that forms a solid foundation for your whole structure.
How many words would someone have to fully understand to understand your physics theories?
Well, it's not a question of how many, but there are some key words, and again, I try to mention them off the top of my head. You need to know what object is for physics, okay, for the purpose of physics. We're saying you need to know what an object is. You need to know what separation between two objects are. You know, you got to call that separation. Something we call it distance or gap or separation. You can use any of those. They're synonym, but distance is a good word. And now you take the set of distances. That's location. Okay, so you have one object here. There's a set of distances to the rest of the objects in the universe, and we will call that the location of that object. In other words, location is always in relation to all the other objects in the universe, wherever they may be. Okay, or you can take a subset of that and say, okay, what is the location within the solar system? And again, you have to take other points as reference. And the best way, I mean, if you want to get very precise about an atom, you just say that the distance, the set of distances of one atom with respect to all the other atoms, be they in the solar system, in the galaxy, in the universe, whatever visible universe, whatever chunk of region you decide to consider. And then you have, you know, words like motion. I mean, in physics, we need to know what the word motion is. And it's interesting that Newton never defined, in fact, in his Scholium, he says, I do not define la, 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 and motion, you know, because we all know what it means. We all know essentially what it means. Oh, no kidding. So we know what it means. Why don't we define it if we all know what it means, what it is? And again, Newton could not define the word motion. And he is credited with 3 laws of motion. So
3 laws of whatever.
Yeah, 3 laws of whatever motion is, you know. So we run into these kinds of contradictions. There are other words as you go along, like, you know, what do you mean by straight? These are lesser words, but they're important in physics as well. What do you mean by straight? Is straight the same thing as rectilinear? Rectilinear refers to motion. Straight refers to an arrow. You know, a physical object can be straight. Rectilinear is how something travels. Then you have the word dimension, coordinate, and vectors. What do those mean? And so you have these series of words that you kind of need to define if you're talking about physics, and if you want to talk about physics in a rational, you know, consistent manner.
How about exist?
Exist, physics is the science of existence.
You better know what exist is.
So you better know what exist is if you're going to do physics, if you're going to be a physicist. And what I'm saying is exist is an object that has location. Because there are objects that don't have location. You know, God is an object. If you at least what was his name, the painter in the 16th century, Michelangelo, he painted God on the Sistine Chapel. And God's got a beard there, he's got hair, he's pointing his finger, so he's got a hand, he's got a finger, he's got legs, he's robed, he's not nude. That's thank God. So he's robed, he's clothed properly, okay? And so to me, it looks like a man. That's my honest opinion.
We have a shape.
Yeah, there's a shape there. So if that's God, let's assume that is God. That's the guy who created the universe. Fine, no problem. You say, this is God. This is who I'm going to... Whenever I say the word God, this is the fellow I'm referring to. No problem. We're done. So now we've got God. And now you can continue with your theory. But then, if we want to talk about the existence of God, again, we have to use the word consistently. And we're not going to talk in ordinary speech. We're going to talk in scientific language. So what do we mean by God exists? Well, we got the object, the guy with the beard. Okay, we got the object. He's got the first condition. But the second condition is location. Does God have location? And what do we mean by location? The set of distances. So we have all these atoms in the universe, or in the solar system, if you want, wherever you want to put God. Let's put them in the solar system to make them, to make the region much smaller, okay? So we talk about whether God exists in the solar system. And what do we mean by that? Well, we mean that every atom in the solar system has a distance from him, from one atom that comprises God, because he's an object. And if he's made out of some other material, fine, no problem. Maybe he's made out of a single piece, fine. But from his chest, there should be a distance to my eye, to my chest, to my ear, to whatever. There should be distance between God's chest and mine. Okay? And then we can say that he exists because he has location. He's got the set of distances from every object in the solar system. And if he's, outside the galaxy, we take it from galaxies in the universe. If he's outside the universe, well, then we have a problem, because now we have to find out whether the famous universe has shape and you can be outside of it. I mean, is the universe, are we talking about space, or are we just talking about matter? Is God outside of matter, or is God outside of space? Well, if God's outside of space, now we got to treat space as a physical object. And if God is simply outside of matter, well, fine, okay, so let's say God has his magic wand, he's outside of matter, and he sees the bunch of matter which we'll call the universe out there. Where is he? Is he in space? Is there distance between his chest and mine still? I mean, he can be anywhere in the fourth dimension for all I care, in the fifth and the 26th dimension. There's got to be a straight line from him to me, no matter where he hides. So then we can talk about the existence. But for people to say, well, we don't know what God really is, he's spirit, and you can't draw a line from him to him, well, then we're not talking science anymore. Because now you've turned God into a spirit in order for you not to debunk their theory. If God is a physical object, if he wants to exist, he better have a straight line from his chest to mine, period. That's what we mean by exist. Otherwise, the person who says that God exists must define the word exist if he doesn't agree with that definition. It's just that simple.
How about the word field when it comes to magnets?
Oh, field. I love the word field. Field. Well, we have poppy fields. We have cotton fields.
I've seen football fields.
Football fields, yeah.
But what's a magnetic field?
Well, a magnetic field, remember the word was created by Faraday? And there are different claims, because there's the verbal pronunciation of that word and what he wrote. And apparently he wrote it there in like 1844, thereabouts. He wrote about the word field for the first time, but he had been already talking about field, as far as I'm concerned, in the 30s. There are some quotes I think I've seen around there, but there's very little information exactly on when the word field was created. All you can say is that it was created for sure in the 1840s, because that's when Faraday wrote about them. And he's the guy who created the word. And what was he referring to? Both him and the guy who tried to analyze it from a mathematical point of view, which is James Maxwell, he took a lot of the experiments that Faraday did, and he tried to put some numbers and equations to it, and he did a pretty good job on that as well. And you got to grant it to Maxwell that he did come up with the equations that describe the behavior not only of magnets but of the field and electricity and light. But what is the issue? The issue is that both Faraday and Maxwell, they both agreed that field in there, in that first it's a region. It's a region like between two magnets. We'll call that a field. Later on it was extrapolated to gravity and said, well, we're talking about a gravitational field like around the Earth.
Well, football field's also a region.
Yeah, but in the football field, you point, you say there's an object there because you can see it. But in the case of the magnetic field between two magnets, where is it? Oh, here it is. You were playing with it. Okay, so here we have two magnets, and you can see if this one doesn't fall too much, they're not very strong. Okay, now I'm going to pull this one out, okay? And now between those two magnets, there's an attraction. I can feel the pull. And we call that empty space, that region in between the magnets, we call that a field, a magnetic field. And so now the question is, what is that? And both Faraday and Maxwell, they said, there's matter in motion. Those specific words are from Maxwell, but Faraday had already said it earlier than that he thought that in that region there's something, some object that he can't see, and he just couldn't explain it. He couldn't describe it, or he couldn't identify it. But they both agreed that a field has matter in motion. There's matter in there of some sophisticated kind.
There's some object moving in there.
Something is moving in there, and that something is what we haven't identified until today. And under my theory, it's the swinging of threads. And one of the reasons I feel strongly about it is that if you put two magnets together, if they're like in this case, I can't put them together here, right? They keep pushing each other away. They don't like each other. They kind of push each other sideways. And what I'm saying is happening there is the threads are swinging. Remember, you have rows of atoms, right? And they're all aligned, and these are the domains of each magnet. They're swinging threads around. The ones on the top go in the same direction. The ones on the bottom go in the opposite direction, but they also kick the other guy out. So here you got like this, and on the bottom here. And the bottom, you got this. And when you put them together in such a way that they do attract, like in this case, didn't fall. Okay, it's not strong enough, but strong enough to hold it for 2 seconds. Okay, here the magnet sticks. And what I'm saying happens there is, again, in that region which we call field between two magnets. Now, they're both, the ones on the top go in one direction. And so when this one comes down, this one comes up, and they kind of grab each other and pull on each other. There's really friction. They go through each other, but there's that friction, fast friction, because they're moving at great speeds. And the closer they are together, the more threads that intervene, the faster they go. They try to come together. So it's like an exponential mechanism. And on the bottom, you have the same thing, but they're going in the opposite. Like if the two on the top are going from your point of view is counterclockwise, the ones on the bottom are going clockwise, okay? And the same thing. So magnet is divided between north and top and bottom, not north and south or positive and negative. You got to cut the magnet lengthwise, and the top part go clockwise or counterclockwise. The bottom go in the opposite direction. And so that's why I think that matter in motion that James Maxwell was talking about is related to these threads. Because with the threads, you can produce attraction, repulsion, and you can turn the magnet around. These are round, so maybe it's not, but you can see that I can turn this magnet around and it still sticks.
If they're strong enough.
They're strong enough.
Like that.
See, is that any better? Yeah. Okay. Yeah, see, I can turn the magnet around in any direction and it'll still hold. And again, if I do it better with a square, cubic type magnets, squarish magnets. If you divide them lengthwise and you turn the magnet completely around 180 degrees, it'll still stick. And you say, how can that be so? And if you see those that were on the top that were going from your point of view clockwise, then when you turn it around, what you get is counterclockwise. The same thing. And the bottom one was already, see, one magnet, and think of these as square, okay? Cubic or squarish, okay? Rectangular magnets. And let's say you divide the magnet in half, okay? So I'm going to get closer here. You divide the magnet in half. The top part swings, let's say, from my point of view, clockwise, from your point of view, counterclockwise. Well, the top of this one, where it's grabbing now, is also going counterclockwise. But if I turn it around 180 degrees, now the counterclockwise is on the bottom, but what is it doing? It's going clockwise. And that's how the bottom one of this one was going, clockwise. So no matter how you turn this thing, it'll always match, and the threads do that, explain that quite well, perfectly. And when you turn them around, they don't like each other because they're clashing on the top and on the bottom. So on the bottom they go like this, and on the top they go like that. And so with the threads you can explain the mechanism here. And you can't do that with quantum mechanics, with particles. How would you explain with particles? And if you can explain attraction, for sure you can't explain repulsion and so on.
The last word to define, since we're on definitions.
Yeah.
I know a big one is the word life. Any thoughts on the word life?
The word life. Oh.
Another one that has a lot of misconceptions that
yeah.
we've talked about many times.
Yeah, we've discussed that subject. I think we beat it to death, right?
Yeah.
Dead horse.
It's not life anymore.
It was dead. The horse was dead. We kept beating it. So yeah, we've discussed with my son the word life so many times, and you know, you try to zero in on a definition that we can live with in science, right? That we can use consistently, rationally. And it's very hard to define words, but you know, you gotta bust your head and find out, you know, if you use this other definition, will it work? So you eliminate many definitions, and you know, we finally zero in on one. And I came up in my book, Why God Doesn't Exist. I came up with a definition. I'm saying that it's that which moves against gravity. Okay, it's a natural object that moves against gravity. And, you know, a rock can't do that by itself. Whereas, you know, an ant can do that. And even before the ant, the first entity that can do that is the cell. And both the plant cell as well as the animal cell, they can both move against gravity. And so that was my definition. Until my son came around and he screwed up my definition and says, well, you know, we got to include some other factors. What if an ant can move against the wind, or a fish against the water? Well, now we don't have gravity really. Now we have another force coming, you know, the river flow, and the fish is going through it.
Well,
you know, salmon.
Gravity isn't the only force.
Right, and so I had to modify that, and that was after the book. I modified it, and I said the path of least resistance. Or in this case, I always say it in reverse. It's that you can swim against the path of more resistance. Okay, if you can do that, then like a wall, it could be a wall. I mean, it doesn't have to be anything fluid. You got a wall, and if you can press against that and maybe even make a hole because you're very powerful, well, then you got life because you can go through it. And again, you know, I limit it to natural objects. That means that not second generation, like, or second level, like we created a robot, we created a toy car, we created an airplane. The airplane moves against gravity for sure. It moves also against the air and so on. But the point is that these are things that we made, and we're talking about things we find out there in nature. If you go to another planet and you find whatever's out there, that's one thing. Another thing is for you to make something and say, you know, I made it and put it on the planet. So I like to use the word natural in the sense that it's what you find out there, not something that we made, or a beaver made. You know, if he makes a house and the house moves against gravity, well, that's living, you know. But no, you know, you got to look at what nature has out there, what you would find. Like when we opened our eyes, our conscience for the first time, and started realizing, you know, how this world more or less is built. it's like that. It's like you still haven't invented, you know, little gadgets that move against gravity. Now you just see what's out there. Those are the objects that are alive if they can move against gravity. And again, the first level is the cell, both plant and animal, and I'm saying that that's what life is. And so biologists, if you look at the definitions today, they're this long, they're 2 to 3 meters long, and they include all the things that life can do, and they have all these exceptions, and nobody agrees with them because says, well, you know, we have all these other systems that, you know, maybe some of them don't grow, others don't reproduce, others, you know, my grandfather, you know, after he was 60 years old, he never reproduced again. Was he alive?
No.
You know, if reproduction is a condition, I guess if you never had a child, then you're not alive.
Well, I think it depends on what you're going to use the word for. That's what gets it all in a...
We're going to use it for science.
Yeah, but even biologists, they try to define the word so that it applies to everything we call life, but that makes it tricky to use.
Right, and that's what I'm trying to say. I'm saying we have to first have a word that we can use in science in general. And then if there are, like, you know, some specific entity out there in nature that does not follow that rule, that does not, you know, cannot fight that, well, no, I guess there wouldn't be any exception. I can't think of one at least. But if there is some exception for some reason, then yes, a specialist would have to redefine the word for his specialty, for whatever he's going to use it for. That's all I can say. But I think that...
For example, the way you use the word species doesn't apply to microbes. So it's how you're going to talk about
okay.
It's how you're going to use the word in your presentation.
Yeah.
It doesn't have to encompass everything that we consider species, for example. It just has to encompass everything that you use in your theory. If you never talk about microbes, for example, you could adequately define species as things that mate and have successful offspring. Microbes obviously falling outside of that because they have mitosis.
Yeah.
But if you're never going to talk about microbes, then it's all right to use that word in that way with that definition.
Yeah, I'm sure that cells don't go out there and have sex with each other, you know, so...
but if you never talk about... If your talk was about cells, then your definition for species in that context would be wrong.
Yeah. But so again, there is a context... in which a lot of these words should be brought up, you know. Typically when we talk about life, we talk about, you know, mammals, we talk about the regular animals. We do not talk about, you know, little bugs on another planet. But if we can come up with an idea of a bug on another planet that doesn't follow the same rules, then yes, then we're talking. Then we have to redefine the word for that purpose, for that context. But in general, I think that the way I define the word is quite proper for scientific purposes, for at least for the majority of the things that we have here on Earth. Okay, folks, tomorrow we have another good day, and we're going to be talking about quantum mechanics. I'm going to start out with that. I want to address an issue there with quantum mechanics. And so we'll see you tomorrow. And I hope you liked the presentation. We'll see you there. Bye-bye.
I liked it.